Recall that ventilation refers to the airflow into and out of the respiratory system, into and out of the airways and the alveoli. Total pulmonary ventilation includes both airways and alveoli, both the dead zone and the air sacs, the respiratory zone. For the average 70-kilogram male, ventilation then can be calculated per minute by taking the tidal volume. Let me show you that really quickly. So our tidal volume, shown here, of 50 milliliters. So one inhalation, one inspiration, one expiration of 500 milliliters is our tidal volume. If we take that and multiply it by the number of breaths per minute, which for a healthy individual can be anywhere between 12 and 20 breaths per minute, multiply those two values, and what we end up getting is the total amount of air, the volume of air that is moved into and out of the lungs per minute. And again, this includes both the airways and the respiratory zone. We refer to that as our minute total pulmonary ventilation, so per minute, total pulmonary ventilation per minute. The alveolar ventilation is different because in alveolar ventilation we cannot count the dead zone. It's not part of that gas exchange that occurs. And so to calculate alveolar ventilation, what we actually need to do is take the tidal volume. And so our tidal volume is still going to be that 500 milliliters. Here's my tidal volume. But now we're going to subtract from that tidal volume 150 milliliters to represent the dead space. And that dead space then, once that's been subtracted from the equation, subtracted from the process, we now have a value of 350 milliliters as being what actually is moved into the alveoli with each inspiration and removed from the alveoli with each expiration. From there, though, the calculations are very similar, and we simply are going to take the number of breaths per minute, which again, normal is between 12 and 20 breaths per minute, to give us our alveolar minute ventilation that you can see here. And so notice my comparison contrast of values: 600 milliliters per minute for total pulmonary respiration, only 4,200 milliliters per minute for alveolar ventilation. So my alveolar ventilation is less. Alveolar ventilation, though, is probably a better estimate as to the ability of the lungs to perform their function. It's more relevant in terms of our ability to maintain homeostasis, because this is actually the air that is exposed to or that is available for gas exchange.